This is the first of 3 lectures for Chapter 3, and the topic is Processes and Process Variables. And this first lecture is going to be on determining the density of liquids and gases. So when we determine the density of a liquid, we need to know something about it. And this is going to be found from the specific gravity, okay, which you can find for many pure liquids on table B.1 in your textbook. Okay, you can also look online or in the CRC Handbook of Chemistry and Physics and other places. Okay, so here's an example. The specific gravity of ethanol can be found in the back of the book as 0.789. And what are these 20 degrees and 4 degrees? The 20 degrees is the temperature of ethanol that it was measured at, and 4 degrees is the reference state, which is water, at 4 degrees. And it turns out that the density of water is exactly 1.000 grams per centimeter cubed, and it's also 1,000 kilograms per meter cubed. So you decide what are the units that you want your density in, and you choose the units of water, and then you just multiply it. So if we want this density, okay, if we want the density of ethanol in grams per centimeter cubed, we simply multiply the specific gravity times 1. And that gives us the density of ethanol in units of grams per centimeter cubed. If you want it in units of kilograms per meter cubed, then you're going to multiply it by 1,000. And then you get 789 kilograms per meter cubed. Pretty straightforward. Okay, but students, some people forget this. So you don't want to forget this. Okay. Then, now if you have a mixture, you can estimate the density of the mixture by either volume additivity, which is what we're showing on this page. Okay, so this is simply 1 over the density of the mixture is going to be the sum of the mass fraction divided by the density of the pure species. Okay, so if we're doing water and ethanol, okay, then we know here the density of water, when the mass fraction of water is 1, then the density is 1. Okay, and for ethanol, when the mass fraction of ethanol is 1 and the mass fraction of water is 0, we have pure ethanol, and the density is 0.789. Okay, so we can get the mixtures in between. These are the mass fractions. Note that 0.8 plus 0.92 adds up to 1 each time. It adds up to 1. Okay, and then we're going to calculate the sum of xi divided by rho I. Okay, and we take the inverse of that to get the density of the mixture. Okay, so you can compare the values by looking at the actual values that are measured, and it's not terrible. We can also look at the method of simply averaging the densities. So we have the same x for ethanol and x for water here, but this time we're going to multiply the mass fraction times the density and sum that up for the pure components. And here, this time we get the sum of xi times rho I, and comparing that with the actual values. For the ethanol water mixture, this method has less error, but it's not always going to be the case. So your quiz is to now calculate the density of acetone, and the units are given as kilograms per meter cubed, and then estimate the density of a mixture of 50% acetone and 50% water by volume additivity. That's in the video quiz. You can find it on Canvas.